Alright, let's begin. First assignment was a fairly straightforward one. We take the star from week 1 and add a color gradient to each of the points. We do this by making sure the center square is a solid yellow and adding the extra colors as appropriate. So that when we run, it starts as yellow and gradients away to each different color. Second assignment was slightly different, a bit more challenging, where we wanted each of the points to be a solid color rather than a gradient from yellow to its color. We do this by, instead of having one point for each triangle edge, we now have a individual triangle for every single point of the star. This allows us to make it so instead of going from, say, yellow to magenta, it now goes from magenta to magenta, which creates a solid color effect, which, as we can see, works as intended. The third assignment was to take the triangle position color assignment and make it triangle color position, so that color is the first parameter. We do this by changing the input layout. So in the input layout, in the position color assignment, color is offset by 16 bytes. This is because a position vector is 16 bytes. So it will, by setting that offset up, it will be read immediately after. If we want to make it so that we have color first, we will instead flip that. So we want color to have 0 byte offset, so that starts at the beginning of the input layout. And we want position to be offset by the size of a color. Colors, coincidentally, are also a size of a vector, so we offset that by 16. And this allows us to have color as our first parameter. And when we run it, it looks as we intended. Final assignment was a bit more of a trickier one. This one asked us to, instead of telling the vertices what color they were, to assign them an index number instead, and to create a array of colors to be read from later. So we will create a constant buffer in order to tackle this part of the question. So the way that this worked is when we made our vertices, we assigned the position, and then, like I said, instead of assigning the color, we assigned each of them a number. So 0 is what's going to become yellow, and 1 is what is going to become red. So we did this then by creating our buffer. We established our buffer settings, created the buffer here, made sure the buffer actually was created successfully, and then we assigned the constant buffer to the pixel shader. This is where the colors will be established. So after that, we took the structure, we took the array, we set the 0 to be yellow like we wanted, and set 1 to red, so that any 0s will be read as the color yellow and any 1s will be read as the color red. Then we updated the constant buffer to read this data. So if we look at our shader, we have our constant buffer, which has two different float 4s, which are our colors, and then the pixel shader, it will take that active color array that we set up and look at the color number of the pixel. So that if the color number is 0, the pixel shader will say this needs to be yellow. If it's 1, it needs to be red. To show the foolproofness of this, if I click, now we have lime as the center and blue as the points. This is because on mouse down, I changed what the array was supposed to be. So now the 0s are read as lime and the 1s are read as blue, and then we updated it as we needed. So as you see, it works as we want. And the final important step is once we are done, we have to delete and release the color object to make sure we don't leak any memory. By color object, I mean the constant buffer. Finally, talking about constant buffers and shader constants. Shader constants are labels that point to constant buffers and texture buffers as well, and reads the data within them during the vertex and pixel shader stages. Constant buffers are small buffers of data on the GPU that can be changed at runtime by the CPU. And constant buffers have a constant value during each execution of the runtime that will not change during that runtime. And finally, any data that it gathers is sent to the shader constant. Last assignment, what we had to do was take this code and put it in our pixel shader to try and get this, but instead of that, we get this. As you see here, we put that in, we get this. The reason that we get this is because during the rasterizer stage, the pixels that are within the bounds of what we make the triangle in between the three verts, that is interpolated based off of the verts from the input assembly stage. So it takes our vertice array and finds those 3 points, and during that rasterizer stage, any pixels within those 3 points are sent over to the pixel shader for the whiteness effect. Pixels that are not within those 3 points are not sent to the pixel shader stage. That's why the whiteness effect only extends as far as the triangle and doesn't go extra, like it doesn't have the bounds of the window, it has the bounds of the triangle because only pixels within the triangle are included during the pixel shader stage. And that is it.